Alright, so the problems, the numerical problems related to this topic are the example 17-1 and the exercise problems 17-1 through 17-6. Since the example is already pre-solved in the book, so I will start from the exercise problem 17-1. So I invite you to take 1 minute to read the statement of this problem from your book. Alright, so if you have read the statement of the problem, it says that we have to find the torque that can be transmitted through a two-surface dry disc clutch. So N is equal to 2 and it is a dry disc clutch. It means no oil has been used to lubricate or to take out the heat from the clutch. Its outside diameter is given as D naught is equal to 120 millimeter. So this implies that R naught will be equal to the half of this, and I will write directly in meters. And similarly, Di is given as 70 millimeter. It means that the inner radius is 0.035 meters. The applied axial force. So axial force is actually the actuation force, which is 10 into 10 to the raised power 3 Newton. It is given. The value of mu is given as 0.4. This is the coefficient of friction. And what is next? We have the condition. The condition is given. It is the uniform wear condition. So it means that these formulas that I just derived are applicable in this problem. So these are the formulas here, you can see that. And is the then it says, is the pressure on the lining acceptable, and what lining material would be suitable? So for that we are going to consult a table from the book later on, but first we have to solve for the torque and other factors. Now since we already have this R naught and Ri, we also have the value of F, right, which is given here. So what we can do is we can actually apply this formula directly in order to find out the torque. So if I find out the T, it will simply be, since there are two surfaces, it will then be 0.4, then it will be the force, so 10,000, right? And then we have the addition of inner and outer radius divided by 2, and the answer comes out to be about 380 Newton meter. So this is your first answer. Now, in order to answer the other questions that has been asked, it says, is the pressure on the lining acceptable? So in order to answer this question, we first need to know what is the maximum pressure that will be applied on the lining. So here in this formula, you can see that we have the factor of maximum pressure and we know all other factors. So if we simply use this formula, we can actually find out P max, which will be equal to F divided by 2 pi Ri and then R naught minus Ri. And if you put in the values of all these factors, what you are going to get is you are going to get about 1820 kilopascal of pressure. Now, is this pressure going to be acceptable for the lining? It depends upon what kind of lining we use. So for that, I invite you to scroll to your student handbook and go to table 17-1. So I'm going to write here, go to table 17-1 on page 230 of your handbook, and here you will see different materials in the leftmost column, and then on the right side you will have the values of factors. The first one is the dynamic coefficient of friction, and in dynamic coefficient of friction we have further two categories, dry or in oil. So remember, in this case, in this problem, we are in the dry category. But anyhow, coefficient of friction was already given. Then we have in the middle column, you see maximum pressure. So the maximum pressure in our case comes out to be 1820. So 1820 kilopascal. Right? Now what you have to find out is that which of the materials in this table have the pressure range greater than 1820 kilopascal. So if you see in the first row molded material, you will see it has the range of 1030 to 2070 kilopascal. And similarly, if you see sintered metal, the third material, it also has a very same range. So for this clutch, we have the suitable lining material of either molded or sintered metal. So that actually answers the question in the problem. Now I invite you to go to, I am going to just grab this one. So now what you have to do is you should solve the problem 17-2, and it is the same statement except that this time you have to use the condition of uniform pressure, right? So do it yourselves. Similarly, after doing this problem, you should go to the example problem 7-1, and this also you have to do yourself. So that is all for this portion of this video.